Hello class. Now that we've mastered trig functions, today we're going to learn about how to use them to solve equations. As usual, some of you are wondering when we'll ever use this. We'll get to that, but there are tons of applications of how to use solving trig equations, and you need to feel comfortable solving them. We've know how to use the unit circle now, we know radians and degrees, we know how to graph them. Now if they're an equation, can we solve them? So looking here at example 1, if you take out your notes, here's a problem where I have x right here. And it's just like regular algebra. What my goal is to basically get x by itself. So you're going to do essentially the same techniques that you've learned all through algebra to get x by itself. First of all, I have this minus 1 here. So what I'll do is I'll add 1 to both sides. Okay, so far. And then what I'll do is I have this 2 right here, so I'll divide both sides by 2. And at this point, there's two things we can do. One is we could think about what values in here do I plug in here that would give me half? Or when on the unit circle is the sign value equivalent to half? And some of you might need to take out unit circle. I may have forgotten about the unit circle. But if I draw it, I know this is a weird drawing, but remember the shortcut I told you is like 1, 2, and 3? So I'll do 1, 2, 3, 1, 2, 3, and then there's square roots and there's 2's over all of them. So I'm going to figure out where sine is equal to half. Remember, sine is the y value. And also remember that for these questions, I know it doesn't say, but we're going to look for all answers between 0 and 360 degrees, or all answers between 0 and 2 pi. So the convention is for math problems like these, there's going to be more than one answer. There's more than one place where sine equals half. But I just need to know between 0 and 360 and 0 and 2 pi, how many answers or how many times does sine equal half? Well, first of all, here, I notice sine is 1/2. And if I follow the unit circle, you'll notice that by reflection or symmetry, it's also going to equal 1/2 here. You can look at your unit circle, or eventually you need to understand it. But sine x equals half at pi over 6, and also on this side at 5 pi over 6. So my answer is pi over 6 and 5 pi over 6. And then, so until you guys get used to degrees and radians, I'm going to ask you to do both, which means the same thing as 30 degrees, or the same thing as 150 degrees. Okay, so that's how you solve a trig equation. Again, we're going to have to look back at our unit circle to remember how to do some of these things. Example number 2, collecting like terms. So that example 1 is the easiest example. Those are the ones that we want. But in this case, you'll notice that, just like in regular algebra 1, I have x's on both sides. So what you're going to do is you want to get both x's on the same side. So what I'll do is I'll put sine x, or I'll add sine x to both sides, which will give me 2 sine x's on this side, plus radical 2 equals 0. And then, now we're back to a similar equation or problem as example number 1. So what I'll do is I'll subtract the square root of 2 from both sides. And I'll divide both sides by 2. Now we're in the same predicament. Where on the unit circle is the sine value, or the y-coordinate, equivalent to negative radical 2 over 2? Well, you know that sine is y, and you know that on this side of the graph, the y is positive. But here on the bottom, y is negative. So my answers, and again, you could look on your unit circle, but pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, it's going to be 5 pi over 4, 6 pi over 4, and 7 pi over 4. And again, I know that because the radical 2 over 2's are the pi over 4, and this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This one here is 5 pi over 4, 6 pi over 4, and then this one is, and this one is 7 pi over 4. So that's how I got those answers. And again, so that until you're comfortable doing just degrees or just radians, we're going to do both. If this is 180 plus 45 is 225. And then I'm going to subtract 45 from 360, which is 350. So here are all the answers. Again, there's infinite answers, but between 2 pi and pi, between 0 and 2 pi and between 0 and 360 degrees, these are the only places where x, or the sine value is equal to negative radical 2 over 2. Alright. What about, this one says extracting the square root. You may notice in this problem is that I have as opposed to the other problems, I noticed that I have this squared here. What am I going to do? Same thing, it's just like algebra 1. I'm going to try to get x by itself. So this looks similar to example 1 and example 2, where the first thing I'm going to do is I'm going to add 1 to both sides. Okay. I'm going to divide by 3. Okay, so far? And then, since it's tan squared equals x equals 1/3, I'm going to have to square root both sides, which means tan x is equal to the plus and minus square root of 1 over radical 3. So again, back to my unit circle, I need to figure out, and there's going to be multiple answers here, where does tangent x equal 1 over radical 3 or negative radical 1 over 3? Okay. So remember, tangent is sine over cosine. So if I scroll back, and again, you guys probably have nicer unit circles, tangent is sine over cosine. And you'll notice that I get that if I do 1 over 3. Or if I do, on this side, if I get the sine here divided by the cosine here. So what happens at this point right here, right? You guys see that? It's going to happen over on this side over here. It's going to happen on this side over here. And it's going to happen on this side over here. So my answers are going to be, again, all the answers. There's going to be 4 this time. It's going to be pi over 3. Oops, sorry. Pi over 6. 5 pi over 6. 7 pi over 6. And 11 pi over 6. And again, if you want to use your graphing, your unit circle, you can take a look at why that is true. Again, it's because I'm trying to find when I get sine over cosine and I get 1 over 3, which is going to be this one over this one. And this is symmetrical to the one over here, the one over here, and the one over here. If I want it in degrees, it'll be 30 degrees, it'll be 150 degrees, it'll be 210 degrees, and it'll be 330. And again, if you're not comfortable doing that, you need to use your unit circle as a crutch. Alright, let me see if I can move this real quick. Alright. Factoring. So here's another example. So the first example was the simplest one. The second example, we had to combine like terms. This one we had a square root, so we square root. So still all examples of basic algebra 1 problems. Now let's add one more level to it. What about factoring? So same as all the previous problems, you'll see here the difference between them is that I have 2 terms now, I have cotangent and cosine. So just like if we had a regular algebra 1 problem, I'm going to move these all to one side. So this is going to turn into cotangent. Cotangent x cosine squared x equals, okay, let's rewrite the problem. And what I'll do is I'll subtract that 2 cotangent x from both sides. And then that'll equal 0 since I mirrored it to both sides. Now, let me just scroll down real quick. So you notice now that I have a cotangent in this term and a cotangent in this term. What I'm going to do is I'm going to factor out that cotangent. So cotangent, if I factor it, this cotangent x, I'll get cosine squared on the first term, and I'll leave me with just a minus 2 on the next term. Okay, so far? Now, by the zero product property rule, or again, if 2 things multiply to give me 0, like this times this equals 0, one of them has to equal 0. So let me just draw a dividing line here. One of these has to equal 0. So cotangent x has to equal 0. Or cosine squared x minus 2 has to equal 0. Make sense? So again, 2 things multiply to give me 0. One of these has to equal 0. So here it says cotangent x equals 0. Remember, cotangent is cosine over sine. And if I look back at my unit circle, cosine over sine, essentially when is cosine ever equal to 0? Cosine is the x value. Cosine is equal to 0 here and here. And if I'm going too fast, you're going to look at your unit circle. Cotangent is equal to 0 here and here, which is going to be, if I scroll back down, at pi over 2 and 3 pi over 2. On the other side, I get cosine squared x equals negative 2 equals 0. Okay, so I'm going to use the space right here because I already got a space. So that means, just like the previous problem, let me move the 2 on the other side. So cosine squared x equals 2. I'll square root both sides. I get cosine x equals the square root of 2. Now, I'm going to try to find the unit circle where, plus or minus 2. Where in the unit circle does the cosine equal plus or minus radical 2? You'll notice that on your unit circle you never have a plus or minus, just a regular radical 2. So you're going to have to use your calculator, or in this case, we're just going to say x equals, because it's not a perfect or clean answer, the cosine inverse of plus or minus radical 2. So technically all your answers can look like this unless they sit on the unit circle. All I did was cosine inverse both sides. So that is how you do those type of problems. And we're going to finish with just 2 more. As you can tell, we're moving up, or we're kicking up one step, one more difficulty at a time. Here I got a sine squared and a sine x. I can't factor this anymore. I can't do any of the processes that I just taught you. So what I'm going to do, and this sort of looks like a quadratic. As a matter of fact, it is a quadratic because I have something I don't know squared, plus or minus something I don't know, and then like a little number out in front. Remember when we used to factor things like that? So what I do, and make this easier on you, let's just say, for now, let's call y sine of x, because it'll make my problem neater. So everywhere I see sine, I'm going to put y. So see you have sine squared here. That's going to mean the same thing as 2y squared. See this minus sine x here? That's going to mean the same thing as minus y. And then the 1 and the 0 stay the same. Now this is a problem you should know how to factor and feel comfortable doing. I'm going to call this 2y, and then over here I'll have y. Again, you might have to brush up on your factoring. And I'll call this minus 1 and plus 1. Because if I multiply these two, I get a minus 1, and then if I do the middle terms, I get a minus 2y and a plus y, so that's how I get that minus y in the middle. Now, zero product property rule again. I have 2 things multiplied to give me 0. So 2y plus 1 has to equal 0, or y minus 1 has to equal 0. Solving for y, I'm going to skip a couple of steps here, y has to equal negative half. On this case, y has to equal 1. So some of you said, like, I've solved it, blah, 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 but the question didn't ask for what y was. As a matter of fact, the original problem didn't have a y. We just changed, to make it neat, y equals sine x. So I'm going to put the sine x back into the problem. Sine x equals negative half, and sine x equals 1. Back onto the unit circle, and again, I'm just going to fast forward this to you. You can look this up. But I'm trying to find out where sine, or the y value, equals negative half, and where does sine, or the y value, equal to 1. This one's the easiest one. Sine is only 1 at one place, which is pi over 2, or 90. In this case, sine is equal to negative half. If I draw my axes, the y values are only negative here and here. And we did the negative half, or the half already, this one right here. X is going to equal 7 pi over 6, or 11 pi over 6, or 210 degrees, or 330. And again, if I'm going too fast, you're going to need to use the unit circle. And now the last one, it says rewriting with a single trig function. You'll notice in this problem, I have 2 trig functions, a sine and a cosine. And as you know, I can't do anything if I have 2 different terms in the same problem. Well, I noticed the sine squared here. And remember, there's only one formula I told you that you need to memorize. Sine squared plus cosine squared equals 1. If I got sine squared by itself in this formula that you already know, sine squared means the same thing as 1 minus cosine squared. I could put this 1 minus cosine squared everywhere I see sine squared in the problem. So 2, 1 minus cosine squared, plus, sorry, that's a closed parentheses, plus 3 cosine x minus 3 equals 0. So now I've got a type of problem that's very similar to the last problem that we did, except for we had to do one additional step. I got here a distributive property going on here, so I'll distribute that 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Now, I'm going to combine my like terms. I have this positive 2 here. I also have this negative 3 here. So I'm going to combine them. Negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. Remember when I do a quadratic, and this is now just like example 5 now, I have this negative out in front. Let's multiply everything by negative. 2 cosine squared x minus 3 cosine x plus 1 equals 0, because 0 times negative 1 is still 0, so I just multiplied everything by negative. Remember last time we just called cosine, or in the last problem we just called y sine. So in this case I'm going to call y cosine. So 2y squared minus 3y plus 1 equals 0. I need to factor this, so it's going to be 2y and y for sure. And to simplify this, I will call this minus 1 and minus 1. So if I multiply negative 1 times negative 1, I get a positive 1, and 2y and negative 2y and negative y give me minus 3y. I'm going to scroll down because I'm running out of space here, and we're not going to do this one anyway. I got two things multiplied to give me 0 now that I factored. So 2y minus 1 equals 0, or y minus 1 equals 0. Y equals half, or y equals 1. So now it looks like I've solved it, but again, I didn't ask for y. As a matter of fact, the question didn't have a y. So what I'm going to do is put the cosine back in. Cosine x equals half. Or cosine x equals 1. And again, I'm just going to fast forward through this. Cosine equals half at pi over 3. And it also equals it at, let's see, pi over 6, 2 pi over 3, 5, 6, 4 pi over 6, 2 pi over 3. And cosine equals 1 just at one place, and that is at 0 degrees, or 0 radians, and 360 degrees, or 2 pi, 0 and 2 pi. So that is how you use trig functions to solve equations. Again, the only thing different, everything here should be review for you. You know how to solve algebraic equations. You know how to get x by itself. So the only thing really new here is you have to look at the unit circle to find the answers, and that probably will be the most difficult part for you. But at least you have that crutch. You actually get to see the unit circle in front of you for your quizzes and your exams and all that stuff. So that's how to solve an equation with trig functions in it. Hope you enjoyed the video.